All right, so here we're going to look at some different types of contactors. So a contactor is really the same thing as a relay, a control relay or ice cube relay. The only difference is that the contacts are designed to handle higher current to control our heavy power loads rather than relays, which are for low current control applications. But the concept of how they work is exactly the same. You have a solenoid with contacts that are attached to it, and when you energize that coil, it creates a magnetic field, which then moves the plunger and changes the state of the contacts. Okay, so here we have several different types of contactors by different manufacturers, different sizes and shapes and configurations. So you just have to look at each one to pick out the details of each one and know the manufacturer's terminal numbers. So one thing you want to pay attention to for picking out a contactor is making sure it has the right current rating for what you are using. Okay, so that the contacts will be able to handle the load that it's going to be controlling. The other thing is having enough contacts to be able to control what you want to. So most contactors have at least 3. Some of them have 4 contacts. So just being sure that you have enough of those. And then the other important thing is paying attention to the coil voltage rating. Okay, so the low voltage that you're going to use to control the contactor to change the state of the contacts. Okay, so those vary as well. So for example, these two right here look almost identical. Okay, the same layout, they're made by the same manufacturer. One's a little bit taller than the other, but otherwise they look almost the same. But if we look right up here where the A1 and A2 is for the coil, we can see that this one on the left is rated for 24 volts DC, and the one on the right here is rated for 120 volts AC. Okay, so the coil is different for these. So we can use either DC or AC to control our heavy power loads. So different ones here by different manufacturers. Each of these use different numbering. So you can see the different numberings for the contact terminals on each of these. Different sizes, different layouts. So here you have 4 sets of contacts, normally open, 2 normally closed, and then another normally open. And then your coil, here's A1 and down here is A2. Similar setup for this one. You have 4 sets of contacts, your A1 and A2. Well, actually this is A1 and A2. 4 sets of contacts. Okay, and these are all normally open on this one. Another one that has all normally open. Okay, so these are labeled L1, L2, L3, and then another normally open, and then the coil is right here. So this is a 24 volt coil for this one. So you just have to pay attention to see where everything is. So you know how to wire it. So this one's a bigger type contactor. So here's your inputs, L1, L2, L3, your outputs from the 3 sets of contacts. And then right here, these two are the coil connection, and this is 120 volt coil AC for this one. Okay, so different sizes and shapes. But the main difference is how much current the contacts are able to handle. Okay, so yeah, this one being very large, it's going to be able to drive a big motor, whereas these would be a smaller application for a small three-phase motor or whatever type of power load that we want to control. All right, so just want to show you kind of how these look inside. So I pulled one of these apart so you can kind of see how they work. All right, so this one is similar to this one right here. So I pulled the top off, took the screws loose here, and pulled the top out. So you have a spring so that when it's energized, it pulls down, and when you de-energize it, the spring pushes it back up to return it to its normal position, the normally open position for the contacts. So that's the spring. So here's the coil. So it's just many loops of wire that when we energize this coil, it creates a magnetic field that pulls this down to close the contacts. Okay, so here's part of the frame, and you can see the shading coil around the metal there, and that's to help with the eddy currents to prevent chatter of the contactor. Okay, so on this top part, this is your movable part. So these are your movable contacts here. So you can see this one's in pretty rough shape because it's been well used. Okay, so you have springs here to help the movable contacts seat properly against the fixed contacts. And you have 4 of them here. So there are 2 normally open and 2 normally closed. So you can kind of tell that by the position. So the 2 on the outside is the normally open, the 2 in the middle is the normally closed, and I can verify that by looking at this. So I got normally open, closed, closed, open. Okay, so the fixed part of the contact is in this top part where your screw terminals are. So each of these have a copper piece here that is part of the fixed contact. So I pulled one of these out. So once you put this together, these just slide all the way in and they stay stationary, and then you have your screw terminal to wire to, so that when the movable part changes state, they make contact like so, okay, when it's all put together. Okay, so that's the inside parts of the contactor, just so you can see that. So again, the main thing you need to know with these is the number of contacts, the current and voltage rating of those contacts, and then what the actual coil voltage is, so that it works correctly with your type of control system, whatever that may be, if it's just a hardwired circuit or even an automated circuit with PLC control or something like that. All right.